Now, we want to look at the situation where probably you have particular terms that you need to work out. If you are given a binomial expansion or a binomial expression and there's a particular term that has to be found out, how do you evaluate such a situation? Let's look at this example. Given that 1 plus 2x all to the power 1 plus 2x all to the power 5, it's a binomial expression. Find I, the first 4 terms in ascending powers of x. I, the coefficient of the sixth term. I, the coefficient of x cubed in the expansion 1 minus x over 2 all into one bracket multiplying 1 plus 2x all to the power 5. How would you evaluate such a problem? Okay, so like you just saw in the question that was put up a few seconds ago, we are going to see how particular terms can be found out in a binomial when you have a binomial expansion being given. So like the question just rightly indicated, we were given a binomial of the form or a binomial expression looking like 1 plus 2x raised to the power 5. And the first part of the problem said that we should find the first 4 terms in ascending powers of x. The first 4 terms in ascending powers of x. So like we've seen in the previous video, that means that the x should be on your second part. And this binomial already has that, so we don't have a problem. The first 4 terms means that our k values is going to span from 1 to 4. Hope that is clear. So we want k values from 1 to 4. Okay, so now let's just go and look at our first term. So our first term, which actually means k is equal to 1. And that will mean that our r is 0. So we're going to have 5 choose 0, 2x raised to the power 0. Then we have 1 to the power 5. So when we resolve that, this is going to give us 1. Then we'll come to our second term. So our second term would have mean our k is equal to 2 and our r is equal to 1. And what does that give us 2? We are going to have 5 choose 1, 2x raised to the power 5, 2x raised to the power 1. Yes, then we have 1 to the power 4. Then we come to our third term, which means our k is equal to 3 and our r is equal to 2. That's going to give us 5 choose 2, 5 combination 2, 2 to the power x raised to the power 2. Then we have 1 to the power 3. Then we come to the last part, which is our fourth term. Because the question says that the first 4 terms. Our fourth term would have k equal to 4 and our r being equal to 3. That's going to give us 5 choose 3 into bracket 2x cubed, then 1 all squared. Good. So when we resolve all that, what do we get? So our first term is going to be 1. Our second term, 5 choose 1 is 5, 2x, that's going to give us 10x for our second term. Our third term, 5 choose 2 is 10, as we know. 2 squared is 4, x squared, so 10 times 4 is going to give us 40. This is going to give us 40x squared. Then our fourth term, 5 choose 3 is also 10. 2 cubed is 8. 8 times 10 is 80. And that's going to give us 80x cubed. 80x cubed. 80x cubed. So if we were to put together all, for the I part, all the first 4 terms in there, we could just say that it is 1 plus 10x plus 40x squared plus 80x cubed. That is going to give you the first 4 terms according to the question. I'm sure that's very simple for us to follow. Okay, let's look at the second part now. Let's look at the second part. In the second part, we are told that we need to find the coefficient of the fifth term. The coefficient of the fifth term. How do you find the coefficient of the fifth term? How do you find the coefficient of the fifth term? Okay, now let's try and find the coefficient of the fifth term. Let me just rub this part off. The coefficient of the fifth term. Remember, when we say the coefficient of the fifth term, what in essence we also imply is that our k is equal to 6. Our k is equal to 6. Remember that the k refers to any term in the expansion. So we want the coefficient of the fifth term, the coefficient of the fifth term, or the coefficient of x in the fifth term. We have to find the fifth term itself, and that is the situation we find ourselves when we agree that our k is equal to 6. And remember, our r is always one step behind our k. R is one step behind your k. So if your k is equal to 6, what that implies is that your r is definitely going to be one step behind it, and that's going to give you 5. I'm sure that's very clear for all to see. So let's just pick our term here. We are saying we want a safe term. So the safe term, this is II. The safe term will mean that our k is equal to 6, and hence our r, which is one step behind it, is going to give us 5. So it makes it very simple for us that we just find the value of that. So that's going to give us 5, choose 5, okay? Then 2x raised to the power 5, and we're going to have 1 raised to the power 0. 5 choose 5, we know is 1, and this one is going to give us 32, because 2 to the power 5 is 32, x to the power 5. So the coefficient of x raised to the power 5, the coefficient of x in the safe term is going to give us 32, because 32 is the constant that is found here. That is also very simple. So for the second part, where we are asked to find the coefficient of x in the safe term, the answer is 32. Okay, now let's look at the other part, the third part. The third part was very interesting, as you saw in the question. We were asked to find the coefficient of x cubed in a certain product. The coefficient of x cubed in a certain product. Now let's just try and put that together. Let's put that together and see what we have. So we'll just take this off. Now, this was a product that we were given in the problem. We were given 1 minus x over 2, then 1 plus 2x raised to the power 5. And the question required of us to find the coefficient of x cubed. The coefficient of x cubed. So what do? We take the first bracket here. Now, when you look at the first bracket, you have 1 minus x over 2. Now, the product simply means that the components or the constituents of this bracket have to multiply some other products from this bracket so that the sum of that is going to produce x cubed. Hope you understand that. Whatever is here should multiply something else in this bracket to produce x cubed. So we take each of them and we try and find who the partner is going to be. So here you have 1. Now 1 hasn't got any x. So what would you need in this second bracket so that if 1 were to multiply that, it will produce x cubed? Hope you can guess. Obviously, if an x cubed has to produce and 1 has not got an x cubed, then 1 has to multiply the term with an x cubed. So in this bracket, we will choose the term with the x cubed. And remember, that in the first part of the problem, when we wrote out the value, let me just code it here for purposes of emphasis. I think we had 1 plus 10x plus 40x squared plus 80x cubed. Remember, this is what we got when we expanded it to the fourth term. Okay, so 1 will multiply the 80x cubed. So 80x cubed will be a candidate here. Now we have x over 2. We are interested in the x. Who should x multiply to produce an x cubed? Already there's an x here. So if we need an x cubed, then this one has to give us an x squared, so that the product of the x and the x squared will produce x cubed. Hope that is clear. So the part that will join in this bracket, this multiplication, will be the x squared component. And that we saw is the 40x squared. So this will be written as 40x squared here. So what then do we do from this? 1 will multiply that. 1 will multiply this. Then this also multiply that. So we put them together. 1 times 80x cubed is going to give us 80x cubed. Then minus x times that. The 2 will cancel that to give you 20. Will give you minus 20x cubed. Hope you can see that. The 2 will divide the 40 to give you 20. Then x to x squared will give you x cubed. So 80x cubed minus 20x cubed is going to produce 60x cubed. I guess we are right. Yes. So the result of the product between this and that is going to give you that. So guys, just keep at the back of your mind. Anytime you have such kind of products where you are asked to find them, take one of the brackets. Usually in the exam, you will have one of them being much more simplified. Take each of them and ask yourself, what term do I require from the given expansion such that if I multiply, I'll get the resultant? Okay, so when you use that, you'll be able to find the appropriate terms and you multiply them accordingly. Hence, the result of this product is going to give you 60x cubed. And since the question is asking us to find a coefficient of x cubed, our obvious answer there is 60. Hope that is clear for you to understand. Okay, now let's pick another example that illustrates this same problem that was given. In the second question, you would see the problem that was given there. Let's deal with that question. Okay, so question 2 under this section, where we are interested in finding particular terms. Find in ascending powers of x the first 4 terms in the expansion of 1 plus 2x raised to the power 7, II, or the B part. Find the 7th term. C, the coefficient of x squared in the expansion of 1 plus 2x all to the power 7, all in one bracket, and in another bracket, 2 minus 3x plus 4x squared. How do you resolve such a problem? Watch. Right, so like you saw in the question that was just showed up there, we've been given another binomial expression here. This is 1 plus 2x all to the power 7. And 3 questions are being asked, or 3 sub-questions are being asked of us. The first of all, it says that we should find in ascending powers of x the first 4 terms. In ascending powers of x, the first 4 terms. So, just like we saw, let's go through this example again. So the first 4 terms will mean that we want our k equal to 1, spanning up to k is equal to 4. Right? That's our first 4 terms. So let's look at our first term. What is our first term? So 7, choose, remember 7 choose 0, 2x raised to the power 0, 1 raised to the power 7. Because our r is 1, our r is 0, remember, 1 step behind the k. Okay, so our second term, 7 choose 1, 2x raised to the power 1, then 1 to the power 6. Our third term, 7 choose 2, because r is 1 step behind our k, so r is 2, 2x all squared, then 1 to the power 5. Then our last term, our fourth term, is 7 choose 3, 2x all cubed, 1 to the power 4. Hope you're okay. All right, so what do? Since we know from our combination theory, our first term is going to produce, our first term is going to give us 7 choose 0, that's going to give us 1. Our second term, 7 choose 1 is 7, times 2, that's going to give you 14. So you have 14x. Then we have 7 choose 2 from combination, that's going to give us 21 times 4. 21 times 4, that's going to give us, that's going to give us 84. Yeah, 84. So this is going to give us 84 x squared, right? Then our fourth term, we have 7 choose 3, that's 35. 2 cubed, 8 x cubed. So 35 times 8, that should give us 280. So this is going to give us 280 x cubed. So our first four terms will be 1 plus 14x plus 84x squared plus 280 x cubed. I'll just quote it at the top, just that it guides us in the subsequent questions. So our first four terms will be 1 plus 14x plus 84x squared plus 280x cubed. So when we're able to do this, we are done with the question for the first part. Now, it also mentions that we should find a particular term, the seventh term. We should find the seventh term. How do we find the seventh term? Remember, seventh term means that our k is equal to 7, and our r being one step behind that is going to give us 6. So how do we find the seventh term? So we want to find the seventh term. Okay, and we said that our r is one step behind our seventh term, which means our r is going to give us k. Our r is 6. So with r equal to 6, how do we find that? Obviously, we're going to have 7 choose 6, 2 to the power x, all to the power 6. Okay, then we have 1 to the power 1. Okay, what is 7 choose 6? What is 7 choose 6? Our 7 choose 6 is 7 times 2 to the power x, which is 64, x to the power 6. And when you put this together, you are supposed to get 448 x to the power 6. So this is your seventh term. This is the seventh term. Are we okay? Now, again, another product was given. We were told to find the coefficient of x squared, where you have 1 plus 2x all to the power 7, multiplying. Look at what was given. Multiplying 2 minus 3x plus 4x squared. So like we saw in the previous example, or the previous example that was given, look at 2, look at minus 3x, look at 4x squared. So we are saying that you need to pick each of them individually and ask yourself, who or what should the numbers multiply to produce the expected result that we want? So let's take 2. Now, since 2 has to multiply a component in here, this is what we got in the expansion. Which of these numbers will we multiply by 2 to produce an x squared term? That's what we want, an x squared term. We want to find an x squared term. So which of them should we multiply to produce an x squared term? Obviously, this is what has the x squared term here. So 2 will multiply 84x squared. And what do we get for 84x squared? 2 times 4 is going to give you 8. That's going to give you 16. So we have 168x squared. Then we come to the minus 3x. This is minus 3x. What should the minus 3x multiply there to produce an x squared? So when we look at it carefully, there's an x. So the minus 3 will need an x. Hence, this will be multiplied by 14x. And what do we get for that? That should give us minus 42x squared. Then we come to the last part, which is 4x squared. So you take the 4x squared. It already has an x squared. So what does it need to multiply in here? Obviously, it needs the constant. So the 4x squared will multiply 1. And that's going to give you, 4x squared there. So we put all of them together. 168 minus 42 x squared plus 4. And that should give us 130x squared, right? That gives 130x squared. Yes. So the coefficient of x in that solution, in that problem, should give us what we find there. So hope that is clear. It's clear for all to see. Hence the coefficient of the x squared in this problem, after you have done the product, should give you 130. So ladies and gentlemen, this is where we end our discussion on how to find particular terms, particular coefficients, and also how you can work out products, the values of products when you have them. Just remember what your R should be if it has got to do with a particular term. If it's a product, pick each of the individual terms within one of the brackets and ask yourself, what are the corresponding terms and what should be their value, so that when we multiply, we can arrive at the expected exponents that we want. Once you're able to carefully go through all that, we should not have any problems in trying to find or arrive at our answer. So thank you very much. In our next video, we would see how we can deal with situations where there are algebraic components in there, letters that has to be found and all that. Thank you very much.